This is the world today, plain of data and information. We watch our favorite series in video streaming platforms. We talk to our friends through mobile applications. We work remotely through our laptops. We shop or play via augmented reality. This is our world today, and these are the things that we all take for granted and can't imagine our lives without them. All the data we generate eventually reside in data centers. Data traffic in data centers is growing at an annual rate of 25%, and the switches have to handle this remarkably increasing traffic. Today's switches have ports that install optical transceivers at speeds of 100 and 400 gigabits per second. But soon there will be a need for an upgrade to the next step of 800 or even 1600 gigabits per second. Efforts to develop such optical interfaces have kicked off. A practical path to the terabit regime is to scale the current 400 gigabits modules, which are based on optical engines, having 4 parallel lanes, each operating with PAM4 at 53 gigabaud. As transceivers are becoming more and more complex, the requirement for their manual assembly and packaging can claim up to 80% of the total cost. The development of components that will integrate multiple functions into one chip is essential, goes together with the need for automated transceiver assembly processes. In that way, the mass production of high-capacity pluggable and mid-board transponders will cost less than €1 per gigabits per second, and low power consumption will become a reality. Terrific project aims to be part of the solution. Terrific will bring together externally modulated laser arrays in the O-band, photodiode arrays, and a polymer chip that will act as the host platform for the integration of the arrays, the attachment of fibers, and the wavelength multiplexing of the optical lanes. The integration will be automated through the development of module-specific alignment and attachment processes applied on commercial equipment. Using these methods, Terrific will develop 800 gigabits per second pluggable and 1.6 terabits per second mid-board modules, having at least 2-kilometer reach. Compared to the current standards, Terrific modules will reduce by 50% the power consumption per gigabit per second and will have a cost of 30 cents per gigabit per second. The performance of the modules will be evaluated in real-life conditions. In other words, Terrific will simplify the design and will identify the bottlenecks in the assembly process, allowing for the first time truly mass production compatible transceiver modules. Isn't it all just terrific? Well, perhaps the future still holds its secrets, but we are giving the answer to a faster and low-cost way to connect, and this is terrific indeed.